3 says to do. Is that right? Then du is equal to 3x squared plus 1 dx. All I did was take the derivative of it. But look what happens. Look what happens. Now what I want to do is, I want to change the problem. Now, agree? Now what I've got in blue there is important enough to where I'm not going to draw arrows through it. So what I'm going to do is I'm going to go around it and I'm going to say, is this much, isn't all of this, doesn't that become du? And doesn't this become u to the 5th? Because we made it that way. So then doesn't this problem that we didn't want any part of become the integral of u to the 5th du? Yes or no?
Yes.
And now can you integrate that really easy? Isn't that then and everybody knows why I put that plus c, right? The rule is, just burn this in your memory. The rule is, when you get rid of the integral sign, you've got to do one of two things. One of them is put that straight line and the numbers on it, or put a plus c. I didn't have any numbers, so what did I do? And we're through, right? You stop right there on a test, and you get a -2. You get half credit for the problem. Why?
Because put your substitutions back where they were.
The problem started in x, right? It has to end in x. So, then don't I say that this is equal to, what is u?
X is the third plus X.
So I have x to the 3rd plus x over 6 plus c.
Is x to the third plus 6 to the 6th power?
Do what?
X to the third plus 6 is to the 6th power.
Yeah, you forgot your exponent.
Yes. Thank you, both of you. Yes. Okay? Now here's a good why question. First, let me just let you look at that for a minute and ask me any questions about what I did. I gave you, the blue is not going to be there, right? Blue's not going to be there. But you're going to use that blue. That blue told you exactly where to start. And I hope you would say, once you get started on it, from then on, it's real easy. Wouldn't you say that? You just sort of let the chips fall where they fall. Agreed? The way you will mess this up is not going back to X. Just remember, if it starts in X, you go back to X. Question. And going back to X is nothing, isn't it? Isn't that just every place you have a U, you put whatever you said it was in the first place in there? Yes.
I know it won't always be that easy. I mean, just an obvious reverse chain rule, but for that particular problem, if that were on the test, and I was able to do it in my head, and I just wrote the answer underneath, I mean, would you count off for something like that? I mean, that's really one step there.
It is one step for me, and obviously for you, it might be for Travis, who's seen this before. I'd say, humor me in my old age. Here's why, Daniel. There are calculators out now that do integrals. And how do I know if you and Travis just put just the answer, that y'all had seen this before and therefore knew how to do it? Or that you had one of those calculators and you don't know one blessed thing about calculus.
Okay, I got you.
So for right now, humor me in my old age. You're going to be old one day, and humor me in my old age. Okay? And there's a place on the test, at the top of my test, it says to write just the answer on the test will result in no credit. And every now and then I have somebody check to see if I mean it. And I rise to the challenge. Okay? And that's because, remember I told you, if the answer is not important to me, it's knowing how to do it. Okay? There's one last question though. There's one last question. I made a big deal about going back to, I got my answer in U, and I made a big deal about going back to X, didn't I? Why didn't I go back to X on that problem?
Did give a number.
You look to after changing the units of integration.
Yeah. Yes to both answers. Here's another one where both answers are right. Daniel said, when you change the limits of integration, you didn't have to go back to X. That's a good answer. Then there's another one is, if I had gone back to X, my answer would have been a what? What did I tell you when you have numbers on the integral? What does your answer look like?
A number.
Anytime you start a problem with numbers right here, your answer is going to be a number, right? So what I'm saying is, if you had gone back to X and gone back to the original limits of integration, you would have gotten a number, right? But since we were already in U, I just went on and finished the problem in U, and I got a number. And guess what? The two numbers are the same, whether I went back to X or not. So what I didn't want to leave you with is, in this problem I just worked, I made a big deal about having to go back to X. But in this one, I didn't go back to X. And the reason I didn't is, I knew that my answer was just going to be a number. Is that not just a number? Do you see any X's or U's in it? And in fact, couldn't you punch it in your calculator and get a decimal number? So what I'm telling you is I would have gotten the same number either way. Sometimes that number is in a different form, but it still comes out to be the same decimal number either way. Everybody okay with that? All right, let's do another one. This is example 2. Does everybody agree that if I had we could work that? Wouldn't you write U as, wouldn't you write that blue integral down there on the board, wouldn't you write that as the integral of U to the 1/2 power? And then all you do is add 1 to it, divide by the new exponent, and live happily ever after. Agreed? Okay. And besides that, which one of my rules does this fit?
It's two.
2. Isn't rule 2 screaming at you? So, I say, let U be equal to 2x plus 1. Then du is equal to 2dx. Where'd the 1 go? The derivative of 1 is 0. That's where it went. Everybody agree? Okay? So now I know I'm going to put this, I'm going to put U in the place of that, right? But I know that 1/2 du is equal to dx. And I'm going to write again, I'm going to say, solve for dx. Isn't that what we did? Agree? And the reason I solve for dx is I want to be able to substitute something in its place that has u in it. Isn't that the name of the game? Transformation. I have to take everything in the original problem and get rid of the x's. Hear me, get rid of the x's. A little bit later you're going to be tempted to keep some x's in there, and I'm going to act ugly over it, because the whole deal is get rid of the x's and have just u's. And that's the very reason I solved for dx, is because I've got a dx up there and I want to be able to get rid of it. Now, I will know if you go right here and just put an equal sign, I will know exactly what you're telling me. I'm not that picky. What I'm saying is I will know that now you're going back to the original integral. Okay? So now I have the integral of the square root of u times 1/2 du. 1/2 came from, I had to substitute something for dx, and that's what it's equal to. Okay? And now my next act is one of the first things you learned about integrals, right? And that is, this then is 1/2 the integral of u to the 1/2 du. We learned that we can just pull a constant out front, and we learned that the square root, you learned that the square root is 1/2 power. So now I have 1/2 times u to the 3/2 divided by 3/2 plus c. I always try to remember, I'll get to talking and I'll forget it before the semester's over, but I hope you will get in the habit of, the minute you get rid of the integral sign, put that plus c. Jake, you have this puzzled look that makes me a little bit nervous, because that usually means that I messed up.
No, I went.
Did I mess something up? What you're quickly going to do, what you are quickly going to do is you're going to skip that step. And what you're going to do is you're going to write it like this. Isn't that the next thing that happens? You invert and multiply. And all I'm telling you is if you're comfortable with doing that, you can go from here to here and I'll know exactly what you're doing. If you're the least bit uncomfortable, take time to write it out. Are you sensing in only a little over a week that it matters how you write things out? So if you're the least bit uncomfortable, put that step in. It doesn't take but a second. And we're now past the point of you being in a hurry and just scribbling things. So given that, just put the step in. And further, the more steps you put in, the more opportunity you give me to give you partial credit. Does that make sense? Remember I told you that I'm here because of you? I don't love that math that much. I'm here because of you. And that means I'm on your side. And the further you can go in a problem and it be right, the more excuse you give me to give you partial credit. Because you're going, you know a little bit more. But all I'm telling you is if you feel real comfortable, that's a step you can leave out. And that's equal to? And I'm telling you, that suits me just fine. That suits me just fine. You know that this is 1/3 u times the square root of u plus c. But I'm telling you, how many of you were in the military? How many of you were in the military? 2? 3? We use a term in the military called do y'all use that term in the Air Force, or is that an Army term? We call that eyewash. And all I'm telling you is all that does is make it look pretty. That's like in the Army, if you got an old Jeep that is a piece of junk and you have an inspection coming up, what you do is paint the Jeep. And what we're doing is we're painting the Jeep right here, because if you were gonna use that in a problem, what's the first thing you would do with it? What's the first thing you do with it? Change it back to this. And what I'm telling you is don't bother. Don't bother. Okay? Of course, if you do, it's okay. Any questions? Feel okay with it? Start some of the homework on it. Start some of the homework and you'll feel better. The problems do get harder. And I'm going to work some of the harder ones on Wednesday. And remember, my last breath on Friday is the end of test 1, okay? And also, for those of you that haven't had me, on Friday, I'm going to bring the test with me. And I'm going to hold in my hand the test, and I am going to describe to you what's on the test. What kind of problems are on the test. We're not going to do any guessing. I'm not going to tell you the problem, but I'm going to tell you what kind of problems are on the test. All I want you to do is know how to do calculus. It's not about guessing. We're not playing a guessing game where you guess what I'm going to put on the test. You're going to know exactly, and then you need to know how to work those problems.